This video is on completing the square, section 2.3, number 12. I'd like to tell you first that your problems are not going to say complete the square. I'm going to show you this as an option, but I'm not going to recommend that you use it that much. If you remember, we have had 4 methods talked about to solve quadratic equations. Factoring, that's very important. The square root theorem or property, that works if you only have a square and a number, no x. The next 2 will be complete the square and the quadratic formula, and out of those 2 you must know the quadratic formula. In your set of notes you have a sheet that looks like the one I'm holding up. It's the method of completing the square, and it says it's the rules, and these are the rules in my own words, so you may want to print those out and look at them. I'm going to work maybe 2 problems just to show you how we're going to do this. There will be a time in circles that we'll talk about complete the square, but I really don't like it for this method or this section right in here. Here's when I would use complete the square. If my leading coefficient is a plus 1, and if my coefficient of x is an even number, then this is a good fit. Coefficient of 1, even coefficient of x. Now to solve completing the square, this coefficient needs to be a 1. Second, you need to move your constant term, which is -6, to the other side. That makes it a positive 6. Now, we're going to work with this middle coefficient, a 2. Forget the sign, just the 2. I'm going to take this 2 and half it. Well, half of 2 is 1. So I have taken half of 2 and I've gotten 1. Now I'm going to square that 1 and I get 1. So I'm going to add a 1 to both sides. Now, on this left-hand side, I'm telling you right now, because you did half, square, and add, you have a perfect trinomial square here, a perfect trinomial square, which factors into 2 binomials that are just alike, which means you have 1 binomial squared. Now, rather than factor this, the quickest way to fill this in is to take the square root of the first term, which is x, the sine of the middle term, which is negative, and the square root of the third term, which is 1. That works every time. Add 6 plus 1 and you have 7. Now we're back at the method we used last, the square root theorem or square root property. We need to get rid of the square, so we're going to take a square root of both sides. If I take a square root of a square root, excuse me, I'm just going to drop that. I have x minus 1, and I'm going to take a square root of 7. Now remember, when I take a square root, I have a plus or minus. Now I need to solve for x, so I'm going to move this -1 over. It becomes plus 1, plus or minus square root of 7. Now remember, my math lab wants this as 2 answers. One will be 1 plus square root of 7. The other answer would be 1 minus square root of 7. Okay, we're going to go over one more problem. Just review. Now remember, I'm not going to ask you to solve by complete the square. This is going to be at your option or your discretion. Here's a problem that, yes, I might solve by complete the square. I have a coefficient of 1. I have an even coefficient. So I'm going to move my constant to the other side. I'm going to half the 6 and get a 3. I'm going to square that 3 and get a 9, and that's what I'm going to add to both sides. Now remember, the left side is going to be a binomial square. Take the square root of the first, the sine of the middle, square root of the last, and that fills your parentheses. 4 plus 9 is 13. Now you need to take the square root of both sides. Left side will be x minus 3. Right side will be square root of 13. That will not simplify. It's a plus or minus. I need x by itself, so I move the 3 over. Your answer would be 3 plus square root of 13 and 3 minus square root of 13. Again, the only time I would use complete the square is for a coefficient 1 and an even coefficient of x. If I did not have that, I would try to factor, and then I'd go immediately, if that didn't work, to the quadratic formula, which we'll look at in the next video.